She has extensive experience in customized residential architecture and interiors that are environmentally conscious and cost-efficient in nature. She was the founder of Idea 49 Architectural Solutions Vadodara in the year 2001 to 2. She was a junior architect at Studio 69 Bangalore and a senior architect at Biomi Environment Solutions Private Limited. She is the founder director of Studio Alaya Projects Private Limited and a teaching faculty at University School of Design and Impact School of Architecture. Without any further ado, I would like to welcome the presenter to deliver her presentation. Welcome, ma'am. Over to you.
Thank you so much, Sunisha. Thank you very much, everybody. Very nice to be here and talk to you about sustainable building construction practices and filler slabs specifically. Give me a moment to start sharing my screen.
I would also like to welcome you today, Lavanya. So nice to be across the
Oh,
screen.
it's so nice to see you. I love you. You can post n number of questions that you have into the chat boxes. I'll be more than happy to answer them as we go into it. Before we even get to filler slabs, I wanted to quickly introduce to you what sustainable construction techniques are about. But number one, do you know what sustainable construction techniques are? We all know about construction, but not necessarily sustainable construction techniques. And the question is why? What is it? What is the reason that most of us don't know about it, though we are from this industry? One is, of course, of education. Unlike today and now that we are so much more aware that we are having this conversation, the education system hasn't really taught us about anything that can sustain or last until now. There is this perception of the pakka and the kacha house, that I cannot live in a kacha house, I have to have a pakka house. And the whole story about the three piglets, where the wolf destroyed all the houses in mud and straw, but could not the one with the brick and concrete cement, right? So the perception of this pakka and kacha house and anything that is built in any of the material, but cement and concrete cannot be good. And then you have this deliberate ignorance, which is created by the media and the corporations, where you see Bob the Builder having these big equipments, big constructions, looking at steel and cement and concrete. And there, again, there is no conversation about sustainability. And that is an ignorance that has been put into our minds because the corporations want to sell a certain material that is going to help a certain part of the world or the community, a very select amount of the community. But I would like to just go back and retract back and just look at all the history that we had, and as a country, how much we already know and how much we've already practiced traditionally in terms of sustainable construction. Do you recognize what building this is? If you do, just put it into the chat box, you can write it down. This is a bunga, which are very common in Kutch. And in 2001, when I was in Gujarat then yet, we had an earthquake in Gujarat, which was pretty huge. And what we observed was that every other structure, which was built in concrete and cement, had in fact fallen down. And a lot of them very far from the main core, the epicenter of the earthquake, were destroyed. But the bungas, they stood still. They did not get hurt. And isn't it curious to understand why that could have been? A lot of the bungas are made with the soil that is available right there, with again leaves and palm leaves and bamboo that they get right around there. And then all these decoration, beautiful decorations are done with the mule dung that they herd. This is another very famous structure. Would you be able to recognize what this is? What is this image of? Put it into the chat box if you remember. Yes, this is the Great Wall of China. It is one of the 7 wonders of the world. And when 581 is when they initiated making it. And this entire long, endless, more than 11,000 kilometers long structure is essentially built in earth, lime wood, and most of it is earth, rammed earth. And it is still standing. Structures from the absolute north of our country to the south, to the east, to the west, have always had a very sensitive approach to the material available locally, what is appropriate for the climate. You look at these houses in Ladakh and Leh, which are built with the soil. They make the quick bricks out of the soil available there. They ensure that the roof is covered in layers of hay to be able to keep it warm. They introduce glass with, again, incorporate wood from the trees that they grow in their properties. Structures on the coastal regions built with laterite, and again ensuring that they have a roof that allows for the spaces to breathe in such a way that it is not so humid and uncomfortable. Similar are these wattle and daub walls and structures built by the locals in parts of Maharashtra, where again, the wattle and daub allows the wall to breathe, makes it much more comfortable within to stay rather than having to utilize anything additional to keep the house or the hut that they make cool. So what are the benefits of traditional construction techniques? One big advantage is it is with the locally available materials. So you don't have to go very far to look for anything. It is climatically appropriate design, meaning it is designed thinking that this is right for this will keep me comfortable. And it's very logical. Everything that you build the space or the building or the structure with can go back to the soil or go back to earth very easily once the building is no more needed. And therefore, the video that we saw right now, where we're talking of waste and production of waste, it automatically minimizes or decides to go away. It costs, of course, much lesser, because what does it cost? It costs only the labor aspect of it. You are putting in the effort, and that's all, because everything else is so much more easily available. It's so easy to maintain the building. And it includes art. There is a beauty aspect of it that you introduce into it because it's your own. Why are we discussing this? The reason that we're discussing all of this is because the architecture and construction industry contributes to more than 36% of the global energy use and more than 39% of the carbon emissions annually. And in India, we generate more than 10 to 11 million tons of waste annually as a construction industry. And as architects and engineers who are learning to want to make the world a better place, the question is, are we really committed to making the world a better place, or just a bigger landfill of waste? But there's also a contradiction here. A country like India, 9% of the GDP comes from this construction industry. So the country is doing better because of this industry. And more than 44 million workers are employed because of this industry. It also helps the workers and the labor community step up into their socio-economic ladder. So we are also adding value. And if there is a contradiction where there is waste and there is harm and there is good, then what is the way that is out of all of this? There is this area of innovations in the construction sector that is desperately needed, where we reach a more sustainable way of solving these problems, not creating waste, but still adding value to the lives of the people we live with. And for that, we have a very simple formula that we usually follow. And in short, we call it RALIS. You can call it RAILS. It's up to you. Where one, as designers, we learn to minimize the requirement itself. Ask people to think of, do you really need this? Look at everything from a climatically sensitive approach. Be advised by the traditions and the innovations, and then innovate them, sorry. Because we already have traditional knowledge. All we have to do is just innovate that. Pick up that, make it something more interesting. Use everything that is locally available, and that doesn't mean in the neighbor's shop, right? Not especially when you live in a city, that is usually the problem, that everything is available, but it is not about just that. What was locally easiest in terms of availability? When we do a site study, for example, before we start designing a building, we look at the site, and when we write down what are the materials available at the site, the first material available is earth. And include the local skills and the craftspeople, because it is important that it is their knowledge and their acumen that also gets incorporated into the building construction and design. Also, they should be able to learn and be able to do better. So the question is, what can I do? What can I do? I'm just a small little, young architect doing, how do I go about this, right? Be a part of this sustainable movement, and the movement created by your college that you can see, where there is an information, there is advice. All you have to do is take it forward, take it further, endorse and support everything around sustainability as a conversation, as a lifestyle, and that itself can be a very big beginning. How do we choose alternative construction techniques? And now we come to the real main agenda of this webinar, where I'm going to start talking about what is it that we can really do. Foundations, for one. Like every building has a foundation, has a wall, and has a roof. You can look at foundations all over again. As a designer, you can start designing very sensitively, thinking about what kind of foundation you are going to choose and why you are choosing that and how that's going to affect the design and therefore the outcome. From arch foundations to rammed earth foundations to stone foundations, you can choose a whole lot. Everything is not about column footings and beams. Walls can be your CSAB or stabilized mud blocks, rammed earth, cob, adobe, flash bricks, wattle and daub. The choice is numerous. Depending on where you are, what you are going to get, you can choose several types of different materials to build the building's walls with. And the roofs can be a whole lot of variety as well. And I'm just jotting down a few right now. Let's say filler slabs, domes and vaults and arched panels and jack arch roofs and flat panels. All of these systems incorporate a whole lot more local material and a lot less steel and concrete. And why is that of a concern to us? As we go into filler slabs, you will start understanding. If there's anything specifically that you want to understand about filler slabs today, I would like you to write it down in the chat room so that I can start looking at that. So this is what is filler slabs and how is it that you would go about them. A filler slab looks like so from above. Cooking would be a very wrong example for a whole lot of you, but most of you must be cooking, I'm hoping, in this lockdown. And there is a cake that's called a pineapple upside down. You put pineapples in the container, put the batter of the cake. When the cake is baked and you turn it around, you have the pineapple slices on top into the cake, and the cake is set. And it looks really pretty. And that's exactly how a filler slab is done. It's as simple as that. You ready the roof, you have your shuttering. There are so many varieties of shutterings that you can do. You ready your shuttering, you put these filler materials, and then you pour the concrete on top. And then when you take off the shuttering, you see the pretty filler material underneath. It's called a filler slab because it's filled in. So you might have three questions, and this is what I'm going to answer today. What are filler slabs? Where can I use these filler slabs? And how do I go about designing them? To answer the first question, what are filler slabs? Do you know who this is? Would anybody want to unmute and tell me who this is?
Laurie Baker.
Thank you. Thank you. Whoever that was, thank you. So this is Laurie Baker, and Laurie Baker was the one who brought this technology of filler slabs to India, and it was supported a lot by HUDCO and the HUDCO movement. He came up with this idea with the intention of being able to minimize. Could everybody be put on mute because there is a whole lot of background sound? Thank you. Laurie Baker came up with this idea because he was looking at minimizing cost and minimizing wastage. Because the Bangalore tiles that were utilized for the roofs of a lot of houses in Kerala, because the sizes varied or they broke, were always, always kept on the side, waiting and, going to waste. And he thought that utilizing them into the slabs and the roof systems would really be a very good benefit. These are some of the buildings that he has designed, and then eventually he created a lot of variations and then started playing a whole lot with the roofs. So he came up with this idea of utilizing two sandwiched Mangalore tiles put together to create an air gap and to be able to minimize or halve the amount of concrete that went in. And that's what they end up looking like, or the buildings that he's done ended up looking like. So I'm going to go over the benefits of the filler slab. All right. So we know that this is what a sorry, I'm not able to go back. Oops. Okay. Anyways, so what are the benefits of, if you all understand the concept of embodied energy, everything that is manufactured or made has amount of energy in terms of carbon dioxide, in terms of, in terms of material, in terms of its footprint that go into it. Steel and concrete, like you see, end up utilizing some of the most of the energy, highest, in fact. What ends up happening is you're able to halve the amount of steel and halve the amount of concrete that goes into making of these filler slabs. The steel becomes lesser because the module of the filler material is much larger. So it usually would have the steel at every 6 inches or 5 or 6 inches. And in this, you would end up having at double the distance, meaning you create a whole lot more. And the concrete also becomes half because the filler material itself is about 2.5, 3 inches. So, half the slab is essentially the filler slab, the filler material. And then the third huge benefit is the thermal insulation. That you would end up, because of this air gap, and if you go back to school, you remember that air is a bad conductor of heat, right? And because you're giving me an air gap in the roof, you are bringing in insulation. And doesn't that really become a big benefit? Because most of the heat into a building is translated through the roof, and the walls do a whole lot less. So if the roof is responsible for the maximum heat, we want to be able to bring in insulation into the roof itself, right? That's where it becomes green. This is a definition, and you can just take a picture of this and keep it in mind. A filler slab is based on the principle that the roofs which are simply supported, the upper part of the slab is subjected to compressive forces because that is where the load is being carried. And the lower part is experiencing tensile forces, which it is not really serving a whole lot of purpose. And therefore, you replace the lower part with the filler material and allow the upper part to have the steel and the concrete to be able to take care of the compressive force. Because if you go back to your understanding, concrete has very good behavior when it comes to compressive strength. It is steel that brings in the tensile strength, right? The next question is, where can I use these filler slabs? For any kind of a slab, in reality, you can use it anywhere, mostly in simply supported slabs, but even otherwise, you can play a lot with filler slabs. And you can ensure that you are bringing in a whole lot of different kind of materials and different filler materials to be able to play with the kind of design that you can have, which is otherwise so boring with the regular concrete slab, because it's just flat, it's just one monochromatic, one kind of material, where here you can play a whole lot with textures and materials. For example, in this case, in this project we did in Gujarat, there was this old Gymkhana building which was 100 years old, and most of the tiles, the monkeys jumped and broke them. And then that same tile size wasn't available. Therefore, we were not able to replace it. But when we did a new structure in the same campus, we decided we would take up all those Mangalore tiles, replace this whole roof altogether new, and utilize them as a filler material for the new slab that was coming. In the process, we were utilizing the material that was getting wasted. We are also bringing the amount of steel and the concrete down. And the filler slabs themselves are done in many, many ways, of course, but you can use it like this to be able to emulate the Atangudi floor on the floor, bring it in this manner. These are what are the hoodie blocks that are very famously known in Bangalore and Kerala. This region produces them. So how do I go about designing them? The third question. There are three things to look at. One is aesthetic, second is structural, and third is the executional aspect. And these are all very concerning, and especially we designers want to know how aesthetically they're going to be, what you can do aesthetically to be able to add value. So you can utilize terracotta tiles of various sizes, plastic waste, coconut shells, a whole lot of creative ideas you can bring into the play. One is, of course, these hoodie block tiles. You can add a spacer so that there is a grid that you create. You could make them all in unison, like I showed you earlier. In this case, in Pune, we did not find a hoodie block because they're only available in the south region, but we found other kind of tiles, and then we added a matka on top of it to be able to create the air gap, which you can't really physically see, but it is still serving the purpose. And the hoodie blocks, when they're placed close to each other without a gap, they look like so. You can add again kadhais and matkas to the roof to be able to bring in a very interesting visual appeal. This is how you can use a Mangalore tiles, which is what we have learned from Lolly Baker. And then Mangalore tiles are used as a sandwich, by the way. And then you see how, some amazing work that Daniel is doing, and you can see these coconut shells that he's using as a pattern to be able to create visual interest also into a filler slab. So it's a big platform of variety of things you can do. This is what Chitra's office had done, where they, picked up all the keyboards that was being thrown away by the neighbor who was repairing computers, sandwiched thermocol on top of it. And thermocol is also waste that does not have another purpose and cannot go back to nature in any manner, but it brings excellent insulation. And then sandwich the two and cast the concrete on top, and you get a very interesting roof there. So yeah, you'll see that aesthetically, it is up to you as a designer what all you want to play with, because there's so much to play with. Your mind is also thinking, can this waste go back to the roof? Because if a building can absorb all the waste that it is creating, how wonderful is that? The second thing is the structural aspect, because that is a concerning aspect for a whole lot of them. A lot of structural engineers are still not very open to alternative building technology. Unfortunately, they also haven't been taught, or they haven't learned the art of it. And therefore, I want to be able to discuss this very keenly. This is a sketch by Laurie Baker, where he has utilized, oops, it went back, where you end up having two Mangalore tiles sandwiched like that, sitting on top of a shuttering, and you have 8 mm bars running in both directions in the grid of the size of the Mangalore tile. The Mangalore tile is usually 10 by 12 or 12 by 14. So then the grid runs in the 12, every 12 and every 14 inches, you end up having the steel. And then on top of this, you're going to be pouring the concrete. So this air gap that is happening between the mangrove tiles is serving the purpose of insulation. At the same time, it is becoming a solid roof on top after the concrete arrives. The way it structurally serves a purpose is this. This is a solid RCC slab where you end up bringing this is the compressive part of the slab, and the bottom part is the part where there is a tensile part. And if you've ever done the calculation for an RCC slab in the structures class, you would know that you have to assume a thickness of the slab to be able to start computing the load and the size of the thickness of the slab eventually, and then decide that, okay, it's going to be this bar, this reinforcement against this thickness. So if you started with if you started with a 5-inch, 5-inch assumption, you may end up at a 6-inch slab. But the problem is that the assumption itself in the RCC starts with a thicker slab, and it is not necessary. And that is exactly why Laurie Baker came up with this thought, that these are the wasteful pockets which otherwise actually don't serve any purpose in the slab and its behavior. And these are the wasteful pockets that you are replacing with a filler material, which is the bottom of the slab. And that is the benefit that you are adding. And there are a whole lot of benefits that it is serving, which you have already shared before. So this is a part of the execution. And because the slab earlier, like I was saying, that structurally, because the slab is now losing most of its part to a lightweight material, the slab and its requirement for steel also becomes much lesser now. And that itself is also a huge benefit, because not only are you using a thinner reinforcement, you're also giving it a whole lot of distancing, which was not there initially. In terms of execution, you would create a surface, which is with the centering and the shuttering, arrange the tiles on top of it, and pour the concrete on top. It's as simple as that. And your material can be anything that you get excited by. Your steel, your electrical points can run into this, and then is when your concrete can arrive. And then you end up finishing it from the bottom, cleaning it. You may paint it with a terracotta-based material, and that's what the end product looks like. This is, of course, your regular RCC slab with the conduits of the electrical going through, such a lot of steel that goes into play. And it looks so boring because it's just one flat, regular concrete slab, but this is what a filler slab can look like, and it costs you half the money. And that's all you can do to play with it. So these are all the examples that I wanted to suit to you. A whole lot of this is a play school we did, where we again had a kabadiwara right next door. So we picked up all the keyboards from him, and then we added that as an interest visually, because, children being children get intrigued by everything around them. So these are the following takeaways that I feel you can note down. One is that any kind of slab can be replaced with a filler slab. Again, filler slab with concrete is not a necessity. There's also a composite way of doing a filler slab. You have a lot of aesthetics that you can play with as vis-a-vis a regular concrete slab, and then it adds value. It reduces the roof's carbon footprint, which is so important. It reduces the amount of steel and concrete that goes into the roof. You can play with a lot of forms also. It becomes more labor-centric, and therefore it helps the social economy, because a country with the size of population that we have, it needs to help a lot more people than to help just the merchants and the vendors become richer. It uses a lot of waste and a lot of lightweight materials that again adds a lot of value. Terracotta-based materials, which brings in social economy, improves in the process. And it adds a lot of thermal comfort, which is a big gain. So if you have a reason to not do a filler slab, you want to think again today. So why should you not do it, right? I'd like to end this my talk by saying this, that I cannot do all the good that the earth needs, but the world needs all the good that I can do. So let's see what is the best that we can do. These are some of our details. This is our website and our Instagram handle. So if you are wanting to get in touch with us and have any questions to ask, you're most welcome. Thank you very much.
Thank you, ma'am. That was indeed an interesting talk. Now moving on to the question and answer session, we have a few questions from the audience. What is LEED certification and LEED certified architects?
LEED certification is a whole different ball game. It is the entire concept of LEED certification came about to be able to what is called as offset the carbon emissions. The countries that are producing a whole lot of waste. They need to be able to prove that they are minimizing the amount of waste and the amount of carbon emissions by utilizing sensitive materials, by doing the right practices. And that is what LEED certification is about. When it comes to the architects, there are only specific, there is a certain exam that you need to appear for, read up information of what LED allows for, and ensure that you are incorporating that into your practice and the buildings. If an architect certifies, who's certified as a LEED practitioner, certifies that this building is LEED certified, is when it gets approved. And there are benefits that these companies and corporations who have done it, that they get after getting a LEED certification.
What is FEROC? What is it used for, and is it eco-friendly?
Did you say FEROC? What did you say?
FEROC, ma'am. FEROC.
Okay, did I speak about FEROC right now? I'm sorry, I do not know what FEROC is.
Okay, ma'am. What is plant-based polyurethane rigid foam?
It is plant-based polyurethane rigid foam. It is what it sounds like, but it is polyurethane. So there is plant material and polyurethane both mixed to be able to create a foam or a lightweight material.
How does sustainability in design impact on the environment?
I just answered that, I thought, through the presentation. So when you practice sustainable practices or looking at everything from the perspective of if it is climatically right, it is locally available, am I helping the local environment, am I helping the local people, then automatically becomes a practice that is able to sustain. So you are able to do this repeatedly over years without it creating a whole lot more waste and harm to the land you are in and the world that you are in. That is why it's called sustainable. So Nisha, would it be possible for some students to pose the questions directly? That's even nicer. Anyways, you can continue.
Yeah,
no.
I think some students can also ask. They can unmute and ask.
Yes.
Madam, in the meantime, I think for an academic interest,
Yes.
could you just elaborate on this carbon footprint?
Of course.
Which is the other way to explain the sustainability.
Absolutely.
So it will help us students a little bit.
Okay.
What exactly is carbon footprint and how these filler slabs actually or directly help us in reducing the footprint of carbon?
Yes. So carbon footprint is literally, the definition is very simple. It is the amount of carbon dioxide that is released into the atmosphere as a result of a certain activity. So it could be in the way you live. It could be from the perspective of how you build a building. It could be from the perspective of how a certain material is made, to even this webinar that we're conducting. So the carbon footprint analysis can be done for everything. Now, how do you look at carbon footprint? You look at everything that we use in terms of energy is basically petrochemical based, or it is coal based. And these are materials that when they combust, like if you remember combustion process, they produce carbon dioxide, and it is this carbon dioxide that you are calculating. And that's when you say that, okay, this material's carbon footprint is lower and this carbon footprint is higher. This is the amount of carbon dioxide this is producing, and this is how much lesser this material is producing. There's also the concept of ecological footprint. So it's not just carbon footprint, it's also ecological footprint. And what do you, when we say ecological footprint, it's also looking at it, how much harm it is doing to the environment for the production of a certain material or living a certain lifestyle. How big is your footprint? So just imagine that the pen that you're using, or the sun, or the specs that Sunisha is wearing, has a certain process of manufacturing. The plastic frame, if it's plastic, the plastic frame might have been produced in China, but the material might have been, might have been availed in certain parts of Arab, because it's basically a petrochemical material from which the plastic is availed. And then there is again a transportation that it went through. And then there is a glass, and that glass might have come from somewhere in the Europe, and then has again gone through a process, and that has again come to this country. So that one little speck that you are wearing, if you map it on the map of the world, will have a footprint that goes that wide. And that is what you talk of ecology. So if everybody's footprint of everything is that large, you would need how many more earths to be able to live a life? And already what we have as resources as a world, we have much lesser than what we can, what the world needs and the people need. So we would need another 2.5 Earths, by the way, if we go on like this. So if all of us try to look at how is it that we can keep it to ourselves, how is it that we can minimize our footprint, that's the way we can add value to the world and make things easier, possible to even continue living. So would that satisfy your question, Ganesh sir?
See, yeah. Because when you were mentioning about this consumption of 50% of concrete, it directly implies on a certain number of bags of cement which is being saved.
True.
And that X number of bags of cement production, saving the production of that saves the carbon emission.
Carbon emission, yes, absolutely, sir.
Thank you, ma'am. It was very appropriate. Thank you.
Thank you.
Any other students?
Sunisha, like any other questions? Please? Yeah.
That's it.
Okay.
Thank you, ma'am.
Thank you.
We will be posting the recording of this webinar on our college website very soon. There's always a room for new idea, a new step, a new beginning. Before wrapping up this session, I would like to take this opportunity on behalf of the entire AAAD team to heartily thank architect Lavannya Goradia ma'am for sharing your valuable time with us and educating us towards the better future. Teamwork is the ability to work together towards a common vision. I would like to thank Architect Siddhartha sir and Architect Kishan sir, the webinar coordinators, and Architect Harshita ma'am, the broadcasting coordinator. I would also like to thank our principal, Ganesh Babu sir, without whom this session would not be possible. Thank you, sir, for introducing us to various speakers around the globe and giving us the exposure. A special mention to Aditya Group of Institution for always being kind and generous in accepting our request. I would also like to thank all the participants for spending your valuable time with us. It is an honor to be a moderator for today's webinar with such immensely talented people on this platform. Stay tuned for yet another informative session. Stay safe and have a nice day. Thank you.
Thank you. Thank you, Sunisha. You're so sweet.
Thank you, ma'am.
Very good job. Thank you. Should we exit? Yes. Thank you.